This video is going to cover attributes of functions. So when we say attributes of functions, this is kind of a list of things we're referring to. So if I were you, I would be familiar with all of these things. Let's go ahead and get started. The first thing that is on this page is in behavior. So in behavior is not very difficult. Basically, what you want to do is say, if I go left, what happens to the line? If I go right, what happens to the line? And when you answer in behavior, generally you're answering with what's happening to the y values of the line. So this is kind of what you do. You go x approaches negative infinity. This means if I go left. This is saying if I go left. So if I hopped on this line and started going left, what would the end of the line be? So when I look at this, I see the end of the line is going down. So that means if I go left, y approaches negative infinity. It's going down. Now, the other side of this, if I go right, so that's as x approaches positive infinity, that means if I go right, because here is positive infinity on my x, here was negative infinity as if I went left. So if I go right towards positive infinity on my x, what is my y value doing? Well, when I look at this graph, I can see that if I go right, my arrow is going up at the end, so y approaches positive infinity. I'm going up. Let's look at this next one. When I look at a quadratic and I think in behavior, my first thought is they're both going to do the same thing. So my answers better be the same. So again, you kind of format it the exact same way. You say, as x goes to negative infinity, that means if I go left, so this one, what is my y value doing? It's going up, so y is approaching positive infinity. Same thing for the right side, so as x goes to positive infinity, that's if I go right on this line, what is my arrow doing? It's going up, so y approaches positive infinity. This next one's real similar to the one that I just did, except they're both going to be going down. So my answers are still going to be the same, but this time they're going to be approaching negative infinity, not positive infinity. All right, this next one, when I look at it, I see that it's a quadratic, so both of my end behaviors are going to be the same. And they're both going down this time. So the way that I would write this in behavior, as x approaches negative infinity, so that's if I go left, this arrow, it's going down, so y approaches negative infinity. And if I go right, so as x goes to positive infinity, my y value is also going down, so y approaches negative infinity. Okay, and this last one kind of gives a good example that it doesn't always have to be negative infinity or positive infinity as your y value answer. X approaches negative infinity. So if I go left, this arrow here does not go down forever. It levels out at 0. So I need to write my answer as y approaches 0. It's not always going to be 0. Sometimes the asymptote could be like 2 or 3. -5, it doesn't matter. It's just wherever it levels out, that's what y approaches. Now this right side is going up, so as x goes to positive infinity, that's if I go right, my y value is going up to positive infinity. Okay, next, intervals of increase, decrease. The first thing that I would recommend in regards to intervals of increase or decrease would be that your answer is going to be with x values. Because you're kind of giving like a domain almost, like a range of numbers between this and this number, I'm increasing. The other thing that I would recommend in terms of increase, decrease is you're reading this like a book, left to right. So this first part, starting at this point and going from left to right, this red section of line right here, all the way till this point up here, is increasing. So when I go to answer it, I just say, okay, from what value to what value? From what x value to what x value? So this x value is at -5. This x value is at -3. So this red section of line is from -5 to -3, and I'm increasing. And you just write it kind of like interval form. Notice I used parentheses when I wrote it. That is because if you think about it, if I was sitting at this point right here at -5, -4, I'm not increasing or decreasing. If I'm just at this point, I'm just sitting there. So you can't use a bracket when you answer increase or decrease. Answer increase or decrease using parentheses every time. Now you have to also look for other sections of line that will be increasing. So from left to right, this section of line is increasing. That's from an x value of -2 to -1. So over here I would go union with -2 to -1. This union symbol, I feel like it's kind of optional, but I think the majority of the time I put it there. Okay, another section of line that is increasing would be here. That's from an x value of 1 to 2. So union with 1 to 2. And then this last section here is increasing. So that is from 3 to 5. So union with 3 to 5. All right, the main takeaway is answer using your x values. Okay, now we'll do decreasing. Decreasing is the exact same as increasing. It's just going down from left to right. So like this section of line right here would be the first section on this graph that is decreasing. And again, I'm going to answer using my x values. So that's from -3 to -2. So my first interval of decrease is from -3 to -2. Again, you use parentheses, not brackets on these as well. This would be the next section that is decreasing. That's from an x value of -1 to an x value of +1. So over here I'd go union with -1 to +1. The next section of decreasing is going to be right here. That's from 2 to 3. So union with 2 to 3. And that's all the decreasing portions of this line. Now, the next thing that we're going to need to cover is maximum and minimum. So the first thing that I would know about this would be the absolute max and mins. That's exactly what it sounds like. The absolute max, the absolute min is the highest spot, the lowest spot on this graph. So absolute max of this graph would be this point right here. Absolute min on this graph would be this lowest point here. It doesn't necessarily matter where it is on the line, it just matters that it's the lowest point, okay? So when you go to answer these, sometimes it'll ask for a value. If it says value, you're kind of going to answer using y values. Sometimes though, in terms of answering absolute max and mins, you can sometimes get away with just putting the coordinate. So like this red dot is at -3, 4. And this blue dot is at -5, -4. So sometimes you can write it like that. Sometimes they'll want you to write absolute maximum of, and you answer with the y value. So like over here, it's -3, 4. So my maximum would be a max of 4. And then you would say at x equals -3. So same thing with the absolute min. Your absolute minimum value is -4. at, and then say where on the x it happens. So at x equals -5. Your local max and mins are a little bit trickier, but they're still not bad. Basically, your local max and mins are going to be all these points that are not the highest, but they're kind of like a hill almost. So let me just highlight them real quick. All right, all those red dots are local maximums, and all those blue dots are local minimums. Let me color code it. So if I was answering this question, I would probably answer with just a coordinate. So local max would be, this first one is at -1, 3. I've got another one at 2, -1. And another one at 5, 2. Notice these points are like where it changes. It's, if I'm on the line, it goes, and then it starts going down. It changes direction, or it changes from increasing to decreasing. That's where these local maximums are going to be. And you can have a bunch of them, but when it comes to an absolute max, there's only one, or an absolute minimum, there's only one. It's the highest, or it's the lowest. So let's keep answering this. My next local minimum would be, I have 3 of them, one here, here, and here. So I'm just gonna write these coordinates. So that's -2, 0. That's 1, -3. And that's 3, -2. So that's maximums and minimums. All right, now my x-intercepts. X-intercept is wherever it hits this x-axis. So these green dots are going to be my x-intercepts. And this one right here at 0, everybody likes to always forget about that one. If it goes through the origin, it's one of your x-intercepts. So please don't forget about that. So in this case, I have 4 of these x-intercepts. And x-intercepts, you can either write it as like x equals and then put whatever it is, so 0, blah, 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 -2, -4, or you can put them as coordinates. So let's just write them as coordinates. That's at -4, 0, -2, 0, 0, 0, and +4, 0. And another thing to kind of think about in terms of x-intercepts, notice that every single y value on these is 0. An x-intercept has a y value of 0. That's really important to know moving forward. Y-intercept, there's only going to be one generally, and in this case, it would be right here. It's wherever it hits this y-axis. So kind of similar to the x-intercepts, but generally on a y-intercept, there's only one. Otherwise, it's not a function. So my y-intercept here would be at the origin 0, 0. And I don't know what it means by examples, so we're just going to kind of ignore that and move on. All right, this next one, it wants the domain of this function first. That's how far left it goes and how far right it goes. Well, on the left, it stops at -5. On the right, so -5. And I wrote a parentheses down just now. That's incorrect. If you look on the far left, it's a closed circle. So that's going to be a bracket, -5. And then on the right, it's got an arrow, meaning it's going to go up and over forever. So it's going to go to positive infinity on the x for the right side. And remember, on infinity, you use a parentheses. Okay, next would be the range. The range is how low it goes, how high it goes. So the lowest it goes would be here, and the highest it goes, it has an arrow. So when I answer range, the lowest is -2, and it's a closed circle, so I'm going to use a bracket. The highest it goes is infinity, and I use a parentheses there. In behavior is next. So this one, since it doesn't have a arrow on the left side, you cannot go like as x goes to negative infinity. That's incorrect. X can't go to negative infinity. It's not part of your domain. So you kind of just ignore that left side. And so you, on this one, I'm only going to answer the in behavior on the as if it was going to the right. So that's this guy right here. That's when my x is approaching positive infinity. So x approaches positive infinity. Y, what's it doing? It's going up. Notice it's an arrow going up. So y is approaching positive infinity. Intervals of increase, decrease, well, we just went over that. That's basically from left to right. If it's going up, it's increasing. So like on this one, I have 1, 2, 3 sections that's going to be of increasing. And then if it's going down from left to right, it is decreasing. So it looks like I have 2 sections where it's decreasing. My increase, remember, you want to answer increase, decrease with an interval of x values. So my x values here, this is at -5, this is at -3. So my first interval of increasing would be from -5 to -3. Union with, my next section would be -2 to 0. And then this last section here would be from 2 to, notice it's an arrow. That means it's going to go to the right forever, increasing. So this one would be from 2 to infinity. It wouldn't stop. All right, next up would be decreasing, these blue sections. So again, just answer with your x values. That's from, this first section's from -3 to -2. Then my next section is from this section right here is from 0 to 2. And those are the only intervals of increasing or decreasing. My absolute maximum, if I wanted to answer with a value, actually, hold on one sec. This is a good example for when there is not an absolute maximum. Notice on this graph, I have an arrow going up. So this line's going to continue going up. So if you say like a maximum of 5, that's wrong, because I could be like, well, this graph's going to go to 6. Or if you say 1,000,000, it's going to go to 1,000,001. So on this graph, there's no absolute maximum. There is, however, an absolute minimum. This absolute minimum, if I wanted to answer with a value, the value where it happens would be at, notice the coordinates -5, -2. So my absolute minimum, you could say it's -2 at, and then say x equals -5. Sometimes your teacher might let you get away with just writing that as a coordinate though. So -5, -2. These local max and mins, I'm going to just write them as coordinates. So these red dots are local maximums, and these blue dots are local minimums. So I'm just going to write them as xy coordinates. My local max, these coordinates, the red ones, are -3, 2 and 0, 4. And then my local min, that's at -2, 0 and 2, 0. All right, now if you see the word zeros, all it's referring to is x-intercepts. So let me clear this real quick. You see this word zeros, you're referring to x-intercepts. So that's these green dots right here, where it hits the x-axis. So there's 3 of them in this scenario at -4, 0, -2, 0, and +2, 0. Your y-intercept is going to be here at this red dot where it hits the y-axis. So this y-intercept is at 0, 4. Notice, I said this earlier, but x-intercepts have a y value of 0. Notice y-intercepts have an x value of 0. That's kind of important to know moving forward. All right, and now this last question, when I look at it, first thing I'm looking for is domain. That's how far left, how far right. This is the furthest left. This is the furthest right. So that's from -5 to +5. Notice both of them have a solid dot. So that means they're going to be brackets, -5 to +5. The range is how low it goes, how high it goes. So I look how low it goes first. This would be the lowest that it goes, and this would be the highest that it goes. So that's from -5 to -1. And it looks like it hits down here, it hits -5. And at any of these locations, it hits -1. So I'm going to be using brackets on both sides of this. My end behavior, this one does not have any end behavior because there's no arrows. Notice if I go left, I stop there. If I go right, I stop there. So I don't have any end behavior. Intervals of increase, decrease. Look at this section right here. Notice that it has a valley, and right here it changes from decreasing to increasing. So this section of line right here is going to be increasing along with this section of line right there. And then these blue sections are going to be decreasing. This one's kind of weird just because this change happens about halfway through. That's okay, just put -2.5 if you have to. So we'll answer increase first. It is increasing from here to here. Remember, you answer that with x values, so that's here's -3, here's -2. It's -2.5 to 0. It is increasing. And then there's another section from an x value of 1 to 5. That's this section here. And it's 1 to 5 because I'm answering with x values. There's 1 and there's 5. Okay, now decreasing would be the blue sections. That's from, here's -3, here's -2, so that's -2.5 to, and it looks like, oh, sorry, that's not -2.5. The left side goes first, so that's from here, that's -5. So it's decreasing from -5 to -2.5. And then it's also decreasing this section right here, which is from an x value of 0 to an x value of 1. So union with 0, 1. All right, this one's kind of weird because my absolute maximum happens here, here, and here. Well, when you're answering absolute maximum, it's kind of like the y value. Remember, we would answer it like an absolute maximum or absolute minimum, if you look up here, of the y value, -2, at these x values. Well, this absolute maximum, since it happens at 3 locations, answer with the y value, so that's -1. And then when you go at x equals, we'll then just put all these points. So that's going to be at x equals -5, at x equals 0, and at x equals +5. My absolute minimum, there's only one of them this time. It's here. It's a value of -5 at, and then find out what x value it's at. It's at here. That's -2.5. Local max, local min. This one does not have any local maximums because this right here is an absolute maximum. I guess you could kind of consider it a local one as well, but I wouldn't put it. I would just leave this as none. Local minimum, though, however, this one does have a local min. It's at this blue dot, so that's at 1, -3. The zeros are the x-intercepts. When I look at this graph, there's not any portion of this line that hits that red line, the x-axis, so there is no x-intercepts. But there is, however, a y-intercept. The y-intercept happens here. That's at 0, -1. That's attributes of functions.